Our next concept is working of windmill. That means how the electric power can be generated in windmills or wind power generating systems. Here, different components are inbuilt in a wind power generating system. How these components are inbuilt in a wind power generating system and how they are working, how they are controlled for the production of electric power from the wind power generating systems. In order to all these aspects we are discussing now. So see here, this is a simple wind power generating system. This wind power generating system having a tower. After wind turbine. Wind turbine means which has blades like this. These are called blades. And after here, this is hub, and this total part is called a rotor. After this is brake. This is gearbox. This is generator used in the wind power generating system. And here it is electrical controls. And after this is the yaw system. And this is a tower. This is a foundation base on. We are constructed onshore. Earth is the base, and here we are constructed wind power generating system offshore. Some other mechanism is there. Why? Because of it is underwater, which is underwater. So here, after generating the electric power, this can be given to the grid. That's why here this is grid connection. So if you are go for the individual component functionalities in the wind power generating system, the first component is blade. What is the need of blade here? So this is called rotor blade. What is the need of rotor blade here? Here, the rotor blade can produces mechanical energy by its rotational motion. When wind strikes on this, when wind velocity is experienced by this rotor blade, which will provide some mechanical motion, that is rotational motion, finally which can produces mechanical energy. That's why to lift and rotates the wind is blown over them, causing the rotor to spin. Most turbines have either 2 or 3 blades. Why? Because if we are using less amount of blades, inertia is less, then finally speed is more. When speed is more, the power generated from the system can also more here. So next one is low speed shaft. Generally, shaft, low speed shaft means which is the shaft of this turbine. The shaft of this turbine is at low speed because of the speed is restricted. That means the wind maximum 25 meters per second. That's why the speed of this rotor wind turbine shaft also less here. That much of low speeds are not suitable for the power production with the help of generator, because of generator does not accept that low speeds, which requires minimum 1500 speed here. Is it? So that's why here this low speed shafts can be converted into high speed shaft further. So here it is that the low speed shaft of the wind turbine connects the rotor hub to the gearbox. So see here, this is the rotor hub, and here this is gearbox. So this is called low speed shaft. This is called low speed shaft. That means inner cylindrical construction arrangement is the rotor shaft. Low speed shaft also it is called. So the low speed shaft is about 30 to 60 RPM. It is not suitable for the operation of generator, which requires minimum 1500. That's why we can use high speed shafts. So see, this is the high speed shaft. This is from gearbox to the generator. Here, this gearbox, due to the mechanism of gearbox, this low speeds are converted into high speeds. So that's why high-speed shaft rotates with approximately 1500 revolutions per minute and drives the electrical generator. To drive the electrical generator, high-speed shaft can be installed in the wind power generating system. And rotor. Rotor means it is a rotating system. Rotating system means wind turbine is the rotating system. Remaining all are fixed. So that's why here blades and hub together form the rotor. That means here blades and hub means, so see here, this one and here. So this is only rotating and this is only rotating. Remaining all are stationary. That's why this is only rotor. Remaining all are stationary systems. So next one is tower. So what is a tower? So here this is a tower. What is the importance of tower? This tower can support this rotor or wind turbine, blades, gearbox, generator, and other auxiliary equipments. So that's why see here, which is made from tubular steel and concrete or steel lattice. This supports the structure of the turbine because of wind speed increases with the height. So here the tower can support the all components. That is one of the advantages. Another advantage is that when height of the tower increases, the power production from the wind power generating system can also increases. Because of for long towers or higher towers, when the height is more, the wind turbine captures more wind energy. That is the reason. When wind energy is more, speed is more, finally what happens? The electrical energy generated by the system is also more here. That is the need of long towers utilization in the wind power generating system. Next one is wind direction. See here, the wind direction, which is a designing of the turbine, which determines the design of the turbine. Upwind turbines face into the wind, upwind turbines face into the wind, while downwind turbines face away because of the upwind turbines can only provide the rotational motion and required rotation, required mechanical energy. If downstream, what happens means the speed of the turbine is at less. Rotation is there, but speed is less. Then power generation is low here. That is the need. Always we require upwind turbines, upwinds. So to rotate in a particular direction with increased velocity or speed. Next, wind wave. So here, wind wave is a communication system here. Why? Because of which can measure the wind direction and communicates with the yard drive to orient turbine properly. That means here, what type of a communication this wind vane provides means this wind vane gives the signal for yard drive. Then yard drive orient the turbine with respect to the wind direction. That is the main advantage of wind vane communication. Is it the first wind vane detects the wind direction? That is the advantage of wind vane. Next, controller. What is the need of controller here? This controller can control the speed. Can control the speed means here see here. Start of the mission at wind speeds of about 8 to 16 miles per hour and shuts off the mission at about 55 miles per hour. That means here when wind velocity is very high at dangerous wind speeds, this controller shut off the wind power generation. Why? Because of there is a damage of blades. That's why the controller shut off the wind power generation. And if when the wind speeds of about 8 to 16 miles per hour, this much of speed, the controller can start the rotation of blades, wind power generation. So turbine do not operate at wind speeds above about 55 miles per hour because they may be damaged by high winds. That is the reason. That's why controller is very essential. An automatic controller is very essential for the wind power generating system to protect the wind turbine and its blades from the dangerous winds. Dangerous winds. Is to brake. What is the importance of brake? So here, this is a brake. What is the necessity of brake? Generally, brakes are necessary for the control the speed, or otherwise to stop the system. That's why here also brakes are used to stop the rotor mechanically or electrically or hydraulically in emergency channel. Controller just given the signals to the brake. After brakes are stops the wind power generation against the dangerous wind speeds. Next, gearbox here, which is very essential. Gearbox, the main complex component in the wind power generating system or windmills, and very costliest component is gearbox. Why here? This gearbox connects the low speed shaft to the high speed shaft. As generally we are observed in the windmill. What happened here? See here. This gearbox connects the low speed shaft to the high speed shaft, right? Which is the intermediate component between low speed shaft and high speed shaft. That means what happened here? This gearbox can convert low speeds into higher speeds. That means 30 to 60 rotations per minute to about 1000 to 1800 RPM. They can convert 30 to 60 RPM speeds into 1000 to 1800 RPM speeds, which is only due to the gearbox. Gearbox is a speed converter here to convert low speed to high speed, because the generator does not accept low speeds. That means at the same time at low speeds power generation is also low. That's why we can, when due to this gearbox, the generator shaft provides high speed, the power generation from the wind power generation is also high. That is the main reason why we are installed a gearbox. Next one is generator. What is the generator necessity? Here, the generator is used to convert the mechanical energy of wind turbine into electrical energy. And here, due to this high speed conversion of gearbox, the generator can produce electrical energy at higher levels, and which is a AC generator. That means the output of generation is AC power. Which type of generator we can use in the wind power generation is induction generator. Why we can only use induction generator? Why don't we can use the synchronous generator? Means wind power generating system requires asynchronous generator. Wind power generation system not want the constant speed generator, because of wind speed is not constant. Wind speed is variable. That means to withstand the variable wind speeds, here asynchronous generator is required. Asynchronous generator means the rotor of the generator speed is greater than the stator speed. That's why compulsory they require higher speeds. That is the necessity to convert low shaft into high speed shaft. Low speed shaft into high speed shaft. Anyway, here generator is used to convert mechanical energy into electrical energy. That electrical energy is the AC. And which type of generator used here means induction generator. Induction generator means which is a asynchronous generator. Asynchronous means which is not at a constant speed. And anemometer. Anemometer means what? Which measure the wind speed and transmit wind speed data to the controller. So earlier we are discussing the controller. What is the function of controller? Controller sends the signals to the brake if heavier or dangerous speeds are exist in the environment, and which can also send the signals to start the wind power generation at the basic speeds, the favorable speeds. So that's why how this controller sends the signals is first anemometer measures the wind speed and transmit that data to the controller. Then controller send those signals to the brake system, then brake stops for against the dangerous wind speeds. So, and also for the starting purpose, for favorable winds also, the anemometer first measures, after sent to the controller, then after controller sent to the low speed stop or rotor system to start the driving of wind turbine or to rotate the wind blades. And knuckle, what is this knuckle? Means here, see here, this total arrangement is called as nagel or nozzle. So that means here the housing of brake, gearbox, generator, yaw system is called knuckle. This total arrangement is called knuckle. All components. That's why here, see here, knuckle is the housing that protects the main frame and components attached to it. It can provide protection for all the components in the wind system, wind power generating system, and also all these components are located in this nozzle. And pitch, what is the pitch here? This is very much essential for the wind power generation system. This is for turbine blades. See here, what is the function of pitch? Turns blades out of the wind to control the rotor speeds and to keep the rotor from turning in winds that are too high or too low to produce errors. Simply, the pitch can control the position of blades on the wind turbine. Due to heavy winds, the distance between two consecutive blades are changes. If those are changes, there is a large disturbance in the power generation. To avoid this problem, pitch control is used. Mainly this pitch is used to control the rotor speed and also the position of blades of wind turbine. And finally, yaw drive. What is the need of yaw drive? Recently, we are discussed in the what is that control where we are discussed here it is wind vane we are discussing here. What we are discussing wind vane? Wind vane is the communication system just. What type of communication if dangerous wind speeds are exist? That type of information is sent to the yaw drive. Or otherwise, if favorable winds are there, that type of communication is sent to the yaw drive. By taking these communication signals, yaw drive can move the wind blades at a dangerous at favorable wind speeds and stops the wind blades at a dangerous wind speeds. So that is the main function of yaw drive. That's why orients upwind turbines. Orientation is rotation to keep them facing the wind when direction changes. Downwind turbines do not require a yaw drive because the wind manually blows the rotor away from it. The yaw drive is only for the upwind turbines. Orientation of upwind turbines. That means this yaw drive can drive the blades of the rotor system initially. Initially, they can drive the blades of the turbine, wind turbine. That's why we can use yaw drive. This is also called as yaw control mechanism. And here it is yaw motor. To drive this yaw control mechanism or yaw drive, yaw motor is used. That means here which can deliver some mechanical power to the yaw drives. And hub of the rotor is attached to the low speed shaft of the wind turbine. So here This type of arrangement is called hub here. This type of arrangement is called hub. So next thing is cooling units. What is the necessity of cooling unit? Here this cooling unit is used for to cool the generator because of heating is produced by the generator. If that heat is sustained in the generator, losses are reduced and finally output power is reduced. To avoid that problem, cooling unit is used. This cooling is provided with the water at the same time. Some oils are also used in the wind system. So these are all the components which are required to generate power, electric power in the wind power generating system. Thank you.